Hi there, my name's James, and for those of you just joining us, right now we're working on SAT Test Number 1, Section 3. This is obviously a math section, and we're going to be focusing on problems 1, 2, and 3 today. Alright, so let's get right into it. Question number 1. Alright, so for each question what I'm going to do is I want to keep track of what information the question is giving us and what the question wants from us, what it wants the answer to be. Alright, so in this question, let's see, question number 1. If x equals 4, which of the following is greatest in value? Alright, so let's break this down. If x equals 4, so that's some information it's giving us, right? So what is it giving us? Gives x equals 4. Which of the following is greatest in value? Alright, so what does it want from us? Well, it wants to know what's greatest in value. So this question wants the greatest or biggest number, right? Okay, so let's see what it's talking about here. Okay, so it's basically giving us x plus 1, x plus 2, variations on that all throughout. Every question or every answer kind of looks the same. So I'd say probably the most surefire way to know you're going to get the right answer is simply just start plugging in 4 for all these x's and see which gives you the greatest or largest value, which is going to give you the biggest number, right? So this might not be the fastest way, and in the end I'll go over a trick to find the fastest, or to find the answer in a quicker way, but for now let's just focus on doing it a straightforward way that we know is going to get us the right answer. So let's focus on A. So what we're going to do is we're going to take 4, because x equals 4, and plug it in to every x we see. Alright, for answer A, it's going to be 4 plus 1 times 4 plus 2, right? Alright, so what's that going to be? 4 plus 1, 5. 4 plus 2, 6. 5 times 6, I believe that's going to get us 30. Alright, so now we're going to do all the others and see how they compare to 30. Alright, so for B, we're going to get 4 plus 1 times 4 minus 1. 4 plus 1, again, 5. 4 minus 1, this time it's going to be 3. 5 times 3, 15. That's not so good. So far, 30 is our champion. Let's keep going, see if we get anything bigger than 30. And also, we'll make a mark that B is now out. C, x minus 2 times x plus 2. All right. X minus 2, let's see, that's going to be 2. X plus 2 again is going to be 6. 2 times 6, 12. No good. C is out. Moving on. D. Well, what's D going to be? 4 minus 2. 4 plus 1. All right. 4 minus 2, going to get us 2. 4 plus 1, going to get us 5. 2 times 5, 10. Not quite 30. Let's rule out D. Alright, finally, we got E. Maybe E can get us out. What's E going to be? 4 minus 4. Well, that's not looking good. 4 plus 4. Alright, 4 minus 4 is 0. Well, that basically ends it, right? I don't really care what this is. It's going to be 8, but really anything times 0 is going to get 0. So we can, right there, rule E out. So what are we left with? Well, none of these guys beat 30, so I guess A is our answer, right? So the answer to question number 1 is A. Now, if you have 20 problems to do for every math section, you really don't want to be sitting there and plugging in 4 for every single x and calculating that all out. That's going to take you way too long. So let's try to think of a faster way we can get the answer. Well, what do we have? 4 is going to be our x, right? It gave us that x equals 4, right? Alright, so if we plug in 4 to any of these error guys, let's just look at what b is going to do. Well, we know we're going to have 4 minus 1, and that's going to be less than either 4 plus 1 or 4 plus 2, right? So we're subtracting more than we're adding back. That really doesn't make sense. That's not going to get us a bigger answer. If this was like x plus 10 and x minus 1, I might see how that could possibly make up for it. But in this case, no, we're using the same term from A and a lower term than A, so that's obviously not going to work. C kind of for the same reason. We're using a term from A and something that's less than a term from A. That's not going to work either. All right, moving on to D, we have a term from A, something less than a term from A. That's not going to work. Now E is a little tricky because E does have this x plus 4 in it. And if we just only looked at that side, well, x plus 4, that's going to be bigger than x plus 1 or x plus 2. But the problem is it gets a little iffy once you have that 4 minus 4 because that's going to get a 0 like we showed. So E is one of the ones where if we look at both parts, make sure to look at both parts of the answer, we can rule that out right off the bat. And so just by using some intuition and seeing, well, we know that these, because they're subtracting ones and twos, these ones are only adding ones and twos, this should get us the biggest answer. And so maybe that'd be a little bit of a faster technique to get the answer for problem one. All right, moving on to problem two. Okay, this one's a word problem. Most people aren't very comfortable with word problems. Sometimes it can be a dangerous area. But I really don't think word problems are all that bad as long as you're able to break them down and express them in more mathematical terms. Okay? So let's look at this. What is this question telling us? And as we go along, I'm going to just kind of mark down what information it's providing us. Okay, trains A, B, and C pass through a station at different speeds. Alright, so that's not much to work with, but I'll just kind of make a note. It's saying, hey, we have a train A, and I guess I'll use a nice robin's egg blue for B. Alright, we have a train A, we have a train B, final guy over here, we have a train C. Alright, sweet. What about them? Let's keep reading. Train A speed, okay, so they're all moving at different, okay, that's right, they're all moving through a station at different speeds. Alright, so train A speed was 3 times that of train B's speed. Okay, so that's pretty important. It's giving us a relationship, right? Train A, 3 times train B. I'm just going to mark that down. It's giving us that train A speed, which I'll represent by just A. Train A speed is going to be equal to, what was it, 3 times B's speed. So really this part of the sentence is nothing more than just this statement right here. So, word problems, although they're excessively wordy, really only are giving us some basic mathematical relationships. Okay, let's keep reading. And it's saying train C speed was twice that of train A's. Okay, well that's important too. So that's telling us train C is twice that or 2 times that of train A's. Alright, so now we've established two relationships. One between A and B, one between A and C. Alright, so that's going to come in handy. It still hasn't quite given us what we're looking for, so let's just keep reading. What was train C speed? Okay, so that's what we're looking for. It wants to know in miles per hour what train speed is. So wants speed of C. All right. And the final bit of information I think is going to be the key to this whole problem. If train B speed was 7 miles per hour. And that's really critical. Why is that critical? Well, look at this. Right now we just have true relationships, but there's no way we could get an actual number out of this unless we have something that we can plug in somewhere, right? Because in the end, all these answers, these are all numbers. These aren't in terms of A or B or C. It wants an actual number. So we need an actual number to start with. And it gave us that. It told us its final bit of information was B equals 7. And that's going to be critical. All right, so let's get to work. Let's start putting in what we have into our relationships. Well, which of these two relationships has a B in it? Looks like this is our only guy, so we're just going to plug in what it gave us. The speed of B was 7. So that means A is going to be equal to 3 times 7, in which case 3 times 7, it's going to be 21, yeah? Okay, good. Now is that what we're looking for? That gave us the speed of A, but we want the speed of C, so we're going to have to keep going. That's a good bit of information because now that will help us because if, as we see over here, we need the speed of A to get speed of C. So we're just going to plug in 21 for A. So that means that C should be equal to 2 times 21, right? A is equal to 21, just plug it right in. Plug and chug. All right, 2 times 21. You can use your calculator, you can use your head. Going to be equal to 42. So in the end, we did find the speed of C. We found it to be equal to 42. I really hope that's one of the answers, and it is. That is answer E. So the answer to number 3 is E. All right, and that's all we have time for. Thank you very much.